Good morning, dears. Today, our topic physics. In the physics, let us learn about measurements. What is units? What is measurements? Now I will explain. I want to 1 kilogram sugar. How can shopkeeper give? We need to measure things for accurate result of sugar. So that is measurement. Simply I am saying one unknown objects. This is unknown quantity. How much quantity? How many kilograms? I don't know. So this is unknown. Unknown quantity measuring with or comparison with known quantity. This is known. Known quantity. Known quantity. Unknown quantity compared with known quantity is called as measurement. So the measurement leads us to a very important topic, that is measurement. Let us understand some terms before with this topic. What are the quantity in physics? Weight. Weight also quantity. Length quantity. Height quantity. Temperature quantity. Pressure quantity. Time quantity. So these are called quantities, physical quantities. Why these are called physical quantity? The quantity that can measured is called physical quantity. For best example, weight. What is my weight? 70 to 6 kg weight. So my weight also measurable. Next, time. What is time? Time now equals to 520. This is measurable. Mass also measurable. Density also measurable. So these are the quantities which are measurable, that is called physical quantity. Physical quantity. Once again, physical quantity means the quantity that can be measured in is called is physical quantity. For example, length, mass, velocity, temperature, area, volume, density. These are example to physical quantities. Why? Because these are measurable things. Next, non-physical quantity. Non-physical quantity means the quantity which cannot measurable, but having certain size, certain amount of affection. That is called non-physical quantity. For example, I love my India. I love my India. So, how much love? Don't know. How much love? Don't know. But I love more. I love more. So, love can't measurable accurately, but having some love on our India. So, that is called non-physical quantity. So, non-physical quantity, best example, all emotions, all emotions. For example, love, hatred, like, dislike, hungry, like that. Sometime. Okay, some best examples. Next, very important thing, MCQs. Depending on this one, MCQs. Which of the following is not physical quantity? Length, mass, time, air. Length is a physical quantity. Why? Because measurable. Okay. Mass also measurable. Time also measurable. Air can't measurable. So the best example is the best example for physical quantity. Length, mass, time is physical quantity. Air is not a physical quantity. Which of these is physical quantity? Physical quantity. Now I want physical quantity. A. Acceleration. B. Like. C. Dislike. D. Hatred. One subject clearly the acceleration. Acceleration is physical quantity because of measurable quantity. Remaining three are emotions. Remaining three emotions. So these are called non-physical quantity. Non-physical quantity. Next, curiosity leads us to dash. Curiosity leads us science. If you know curiosity, science is not there. Physical quantities. What is physical quantities? Physical quantities means any quantity which can measure directly or indirectly, or in terms of which any laws of physics can be expressed, is called physical quantity. There are two types of physical quantity. Actually, another type also there, that is called supplementary. Supplementary physical quantity. Actually, two types naye, three types. Mostly explain physical quantities are different types of physical quantities only two. One is the fundamental derived. Another one is there supplementary physical quantity. Fundamental physical quantity, fundamental physical quantity 7, derived physical quantity not limited, supplementary physical quantity only 2. So that's why what I'm saying, fundamental physical quantities are limited physical quantities. Limited. Why? Because 7. And derived physical quantity unlimited. Unlimited physical quantities. So many physical quantities are the derived physical quantities. And the supplementary physical quantities, only two supplementary physical quantities. That's why supplementary physical quantities are limited supplementary physical quantities. Next, what is the fundamental physical quantity? It's very important thing. A physical quantity which does not depending on other physical quantity for its measurement is called fundamental physical quantity. That means fundamental physical quantity means not to depend, not depending, not depending on other physical quantity, other physical other physical quantity. See, fundamental physical quantity, SI unit and symbol, length, meter, unit is meter, symbol m, small m, mass, kilogram, kg, time, second and s. Thermometric temperature, nothing but to temperature. So Kelvin, K. Amount of substances, mole, MOL. Electric current, ampere, that is A. Luminous intensity, candela, CD. Luminous intensity is nothing but to brightness of light. Okay, keep in your mind, sir. Luminous intensity is nothing but to brightness of light. Supplementary physical quantity only two. Okay, so supplementary physical quantity, there are two supplementary physical quantity. One is plane angle, radian, RAD symbol, and second one is solid angle, sterradian. One more, SI unit is sterradian. So angle incredible by the surface at the point is called solid angle. See, so this is solid angle. Fundamental units are always 7. Next, derived physical quantities. Derived physical quantities. What is derived physical quantities? Derived physical quantities means the physical quantity which is derived from the fundamental physical quantity is called derived physical quantity. Simply what I'm saying, derived physical quantity means dependers, depending, depending on other physical quantity, depending on other physical quantity. Other physical quantity means nothing but to fundamental fundamental physical quantity. Fundamental physical quantity. Example, area, density, force, acceleration, work, etc. etc. Why? Because I have to give one best example. Area. Area equals to area equals to length into breadth. Length also nothing but to length, breadth also nothing but to breadth. Density. So density equals to mass by volume. Next one, force. Force equals to mass into acceleration. 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 So force depending on mass and force depending on acceleration. Here mass depending on density, density is depending on mass, density is depending on volume. That's why what I'm saying, area, density, force, acceleration, work. These are best example to, okay, these are best example to derived quantities. And one more thing, one more very important note point in this one, important note point. For example, distance, distance and displacement and length and radius and focal length and height, height and thickness. Once observe clearly these examples, distance, displacement, length, radius, focal length, height and thickness. All are having same fundamental unit. Means all are coming from only one fundamental unit. That is called length. Length. Length is a fundamental fundamental quantity, fundamental quantity. That's why distance is fundamental quantity, displacement also fundamental quantity, length also fundamental quantity, radius also fundamental quantity, focal length also fundamental quantity, height also fundamental quantity, thickness also fundamental quantity. Don't forget, sir, this is very important thing. Note point. So this note point is very important. Don't forget anyone. Some derived quantities. Velocity, meter per second units. Velocity equals to displacement by time. Already this one explained before. So velocity is depending on displacement and time. Acceleration, velocity, time, work, force and displacement. That's why velocity, acceleration, speed, density, these are example to derived physical quantity. Okay, some questions about quantities. A quantity that can measured is called as physical quantity, non-physical quantity, and either B or C. Answer is physical quantity, measurable. And the physical quantity which are expressed in terms of more than one fundamental quantity is called derived physical quantity, fundamental physical quantity, and supplementary physical quantity. Example, derived physical quantity. See, this is explanation. There are dash fundamental physical quantities are there: 7, 3, 6, 16. How many? 7. Length, mass, time, electric current, thermodynamic temperature, amount of substances, luminous intensity of light. So there are 7 fundamental physical quantity. Acceleration is a derived physical quantity which depends on dash fundamental quantities: 2, 3, 5, 0. 2 only, because velocity equal to displacement by time, acceleration equal to velocity by time, means displacement by time square, means displacement is nothing but length. Charge is a dash quantity, fundamental, derived, non-physical, supplementary quantity, derived quantity. Because of current equal to charge by time, now I want charge equal to current into time. So current and time both are physical, fundamental physical quantities. So before I have to give one problem. Okay, very important problem. Okay, find the find find the odd one, odd one out. Find the odd one out. A radius, B speed, C length, D current. Which is the odd one? Which is the odd one? So that's why what I'm saying, radius is fundamental physical quantity, length fundamental physical quantity, current fundamental physical quantity, speed is derived physical quantity, derived physical quantity, speed is derived physical quantity. It's very important thing, sir, very important. Units, measurable quantity, physical quantity. Example, mass, length, time, area, force, pressure, etc. A physical quantity is magnitude and unit. It's very important, sir. Every physical quantity has magnitude and units. Magnitude is nothing but one positive number. Positive number, magnitude. Magnitude is a one positive number. Understood? Positive number. Any physical quantity have one magnitude and one unit. Example. On best example, I have to explain distance. Distance equal to 25 kilometer. Okay. What is the actual meaning? Distance 25 times magnitude of 1 kilometer means see. So 25 is the numerical, means magnitude, and kilometer is the unit. So magnitude is nothing but numerical, magnitude is nothing but numerical. Understood, sir? So that's why what I'm asking, unit is standard reference which is used for measurement of a physical quantity. Unit. In this unit, what is the meaning of unit? How many types of units? Unit means measurement of any quantity involves, okay, comparing with the certain basic, okay, arbitrarily chosen, internationally accepted reference standard is called unit. The unit for fundamental physical quantities are called fundamental unit. The units of all physical quantities can be expressed as a combination of the fundamental unit is called derived unit. Unit. So this is very important thing, sir. In some wrong ways, unit were considered were physical quantities used to be measured. Length was measured with the help of hand, but all hands are slightly of different sizes. For example, kids compared with kids. Okay, adult persons compared with kids. The palm of the hands palm of the kids very less, very small compared with the adult and stage persons. So the length is not exactly right. One subject clearly in down examples. First, small kid. Okay, baby hand. Last one is adolescent hand. So totally different types of. Next. One more thing, one best example, but what if a very short and very tall person walks? What happen? Tall persons moving fast and small persons, okay, short persons not moving fast. Okay, so 1 league equal to distance covered in a 1 hour by walking. So the unit of the unit the unit should have certain characteristics. Every unit have certain characteristics. So first of all, the units must be acceptable in our world. Characteristics of unit. First, for example, one best example I explain, other than we can understand that one. We have weight measures of only 100 and 200 grams. Okay, but I want measure the weight of my elephant. The unit must be suitable size and easily available. This is very important thing, sir. Very important thing. Very important point for characteristics of unit. The unit must be suitable size and easily available. That means anyone can be measured the with unit. Can measure the physical quantity with the unit. A unit should be easily available and reproducible at any place required. For example, kilogram, kilogram, kg. Okay, in India also kg, same one. And Uganda also kg is same thing. South Africa kg is same thing. At anywhere kg is same thing. Next, characteristics of a unit. Characteristics of a unit. The unit must be universally accepted. Universally accepted. Okay, all countries must be accepted that one. Next, characteristics of a unit. A physical unit must be invariable and well defined. It should not be perishable. Relation between magnitude and the unit of physical quantity. Dear students, this is very important topic. Relation between magnitude and the unit of a physical quantity. This topic is very important thing. Understood? The numerical value obtained. The numerical value obtained on measuring physical quantity is inversely proportional to its unit. That's why what I'm saying, n is proportional to 1 by u. So I have to give one best example. For example, I have 5 kilograms of sugar. I have 5 kilograms is equals to 5,000 grams. 5 kilograms is equals to 5,000 grams. Once observe clearly, sir, units, numericals, two parts are there here. So numericals is increases. What about units? Decreases. Units also decreases. That's why in case units is increases, numerical value decreases. Numerical value decreases. That's why n is numerical value. N is proportional to 1 by u. 1 by u. Next. So n1 u1 equals to n2 u2, where n1 and n2 are the numericals values and u1 and u2 are the units of same physical quantities in different systems. Dash is the standard used for the measuring of physical quantity, derived quantity, fundamental quantity, unit, quantity, unit, and system of units. Various systems of unit: FES system, CGS system, and MKS system. FES system stands on foot, pound, and second. CGS system stands on centimeter, grams, and second. And MKS system stands on meter, kilogram, and second. CGS system. CGS system C stands on centimeter, G stands on gram, S stands on second. C means centimeter, measuring unit for length, gram unit for mass, second unit for time. MKS system, meter, M stands on meter for length, K stands on kilometer, kilogram for mass, second S stands on second for time. FPS system, foot units for length, pound units for mass, second units for time. See, Best example. When the scientists used the meat internationally, they had a problem. Yes, they had a problem. Why? Because different units are there in different countries. So they decided to one standard unit. Okay, we can get to one standard unit. So finally come to conclusion by General Conference on weight and measure in 1971 for internationally uses. Okay, in scientific, technical, industries and commercial work at farms. That is called standard units. Which of the following is the characteristics of a unit? The unit must be universally accepted. The must be inversible and well defined. It must be suitable size and easily available. All the above. A standard unit is necessarily for the sake of accuracy, convention, uniformity, all the above. All the above. Yes, see. Thank you, sir. Thank you so much. We will meet in next class. Thank you. Thank you so much.